Ever wonder why two seemingly identical reports about the global economy or the latest AI breakthrough can feel so different? The numbers might look similar, but the story they tell can be miles apart. In an era where data drives everything, from stock market predictions to election outcomes and even the algorithms shaping your social feed, truly understanding those numbers isn't just smart, it's survival. We're constantly bombarded with averages: average income, average success rate, average engagement. But relying solely on these single figures is like trying to navigate a dense fog with only a single streetlight. It obscures the hidden patterns, the critical disparities, and the surprising truths lurking just beneath the surface. Take the mean, for instance. It's what most people think of as the average. You add up all the values and divide by how many there are. It's simple, intuitive. But imagine analyzing the net worth of a group where everyone earns a modest income, and then Bill Gates walks in. Suddenly, the average net worth skyrockets, making it seem like everyone is wealthy, even though 99% remain exactly where they were. This distortion is precisely why relying on the mean alone can be profoundly misleading, especially when discussing economic inequality or market volatility. Now, consider the median. If you line up all your data points from smallest to largest, the median is the value sitting right in the middle. It's the true middle ground. In our Bill Gates example, the median net worth would barely budge, giving a far more accurate picture of the typical person's financial situation. When news reports discuss average housing prices, the median is often a more reliable indicator than the mean, as it's less affected by outlier luxury properties skewing the perception of affordability. Then there's the mode, the value that appears most frequently in a dataset. This is incredibly useful for understanding preferences or common trends. Think about a new tech product launch. If the mode of user feedback is confusing interface, that's a critical signal, regardless of the average satisfaction score. Or, in social media, the mode can reveal the most common emoji used in response to a viral post, offering immediate insight into the public's primary sentiment. The critical takeaway? No single measure of the center tells the whole story. The mean, median, and mode each offer a unique perspective. In today's complex landscape, from geopolitical risk assessments to analyzing AI model performance, ignoring one for another can lead to flawed decisions and a complete misunderstanding of reality. We need all three to piece together a more complete narrative. But even these three powerful statistics only tell us. They don't reveal anything about the ore of the data. Does everyone cluster tightly around the average, or are there vast differences? This is where data visualization moves beyond simple numbers and allows us to truly the distribution. Enter the histogram. Imagine a bar chart, but instead of showing distinct categories, it groups numerical data into bins and shows how many data points fall into each bin. It's like looking at a mountain range. You instantly see the peaks, the valleys, and the general topography. For instance, a histogram of user engagement times for a new app might reveal that most users spend either very little time or a lot of time, indicating two distinct user groups, a pattern a simple average would completely obscure. Histograms can expose hidden patterns. A dataset with two peaks, for example, might indicate two separate populations within your data, like early adopters versus mainstream users of a new AI tool. Or a long tail extending to one side could point to extreme outliers, such as the disproportionate impact of a few high-value transactions on overall sales data. This visual context is invaluable for understanding the true nature of a problem or opportunity. Another crucial visualization tool is the box plot. This compact graph neatly summarizes 5 key numbers: the minimum value, the first quartile, the median, the third quartile, and the maximum value. It provides a quick visual of the data's spread, its central tendency, and highlights any outliers that sit far outside the typical range. Box plots are incredibly powerful for comparing distributions across different groups. Imagine comparing the performance metrics of an AI model trained on different datasets, or the carbon emissions from various industrial sectors. A box plot can quickly show not just which group has a higher median, but also which group has more variability or a greater number of extreme values, giving us a far richer comparison than just looking at individual means. In a world increasingly shaped by algorithms and data-driven decisions, from how news is curated to how resources are allocated, understanding these fundamental statistical tools isn't just for data scientists. It's for everyone. By mastering the mean, median, mode, and their visualization through histograms and box plots, you gain the power to decipher complex information, challenge misleading narratives, and truly comprehend the hidden dynamics influencing our rapidly changing world.